All right, we're going to go ahead and start. My name is Boone Cabal. I'm a software engineer from Oregon. And let me go ahead and start from the beginning. There we go. So we're going to be demystifying monads using the Pymonad library. And the sections we're going to be covering are the sections you can see listed here. All right, let's go ahead and start with pipelines and monads. Back in 2000, when I was in college, I was taking a Unix course in college, and I remember distinctly a lesson on piping commands on the Unix command line. You can see an example here of a sort command. We're sorting a record in a text file, and then we're piping the output to a unique function. Let me just make sure. Okay. Sorry about that from current. I just lost my spot. Sorry about that. Sorry, okay, from current. Sorry about that. So anyway, we have an example of piping commands on the Unix command line. So we're piping the output of the sort command into the input of another command, which is the unique command. And then it's doing a transform, and then it's piping the output to another command, which is the head command. I remember having a couple of observations about this during class. One is, I thought this was a very elegant way of solving certain kinds of problems because with pipelines or with Unix piping, you can compose more complex kinds of tasks using smaller, well-defined commands. So you can do things like change the order of the commands being used. And because every command is well-defined and small, it's easier to test. And I remember thinking it would be nice if you could do something like this in code. You keep in mind this was back in 2000. You can do something like that with functions, but I kind of like the syntax of it. So the way that a pipeline works is you have a data object coming into your pipeline, and think of a pipeline as sort of like a linked list where you have nodes, and each time the data object comes into a node, the node will perform some kind of operation on the data, and then it'll return another data object, which is then piped or propagated to the next node in the pipeline. What the monad design pattern does, does a couple of really important things. First, a monad wraps the underlying data that's being passed through the pipeline. And also, each time a data object visits a node, you're allowed to pass a function in that receives the data object and does something with the data object and then returns another data object. So it's important to understand that in a pipeline, it's important to understand the signature of the function being passed in. Specifically, the function has to receive the data object, and then it has to return some data object. So it has to receive at a minimum one parameter, the data object. One example of method chaining is you can see here with this example snippet of JavaScript. It is creating presumably a person object. It's setting the first name, the last name, the age, and then the final operation of the method chain is it's creating a string version of the person. The way that you can implement method chaining in any class is to have every method return a reference to the this reference, which is a reference to the underlying object. Notice here that the set first name is only receiving one parameter and it isn't the data object. The reason why is that in a couple of languages, object-oriented languages like C++ and Java, in JavaScript, the first parameter being passed in is hidden. It's actually the this reference. So set first name is actually receiving this and the first name. So this is the data object being passed in, and then we are changing the state of this object by assigning the first name to the fname value, and then we're returning the data object, which is the this reference to the object. So if you're working with a language that conceals the this reference, it can make it kind of weird to learn how monads work. Method chaining is impure. In other words, it's impure from a functional programming standpoint. I have some quotes taken out of a really good book called Functional JavaScript by Michael Fogus. And what he says that's really important with method chaining is the problem with method chaining is that every method that is operating on the data object being passed is actually doing a side effect, because in the case of the JavaScript we just looked at, we're creating a person, and then all of the methods are mutating the data of the underlying object. So it's sort of the same problem of a global variable. You have several functions that are all accessing the same data. Ideally, you would want, when you construct a pipeline, here's an example of a pipeline in Python. You would want all of the functions that you pass into your pipeline to both receive and return immutable data. This is a Unix equivalent of the pipeline from the previous slide. Suppose that every single one of these, say, Unix commands was secretly mutating some global data somewhere. That could be kind of a problem. The advantage of adhering to the contract that the monad implements is that every method, or I'm sorry, every function in the pipeline is not affecting data outside of the pipeline. It's all of the data transformations are occurring within the pipeline. Okay, so if you look at this pipeline right here, it is entirely possible that any one of these functions can fail. For instance, the get businesses function could fail. The sort function could fail. So what the monad pattern does is it implements its own kind of monad exception handling or control flow. Conceptually, a pipeline is linear. It appears to be linear, at least. Internally, it's actually implemented using two channels, a failure channel and a success channel. In monad nomenclature, the left-hand channel is known as the left-hand path is the failure path, and the right-hand path is the success path. So let's take, for instance, look at the get businesses function on the right-hand channel. The way that it works is if the get businesses function fails, if something causes it to fail, it'll cause control flow to detour over to the left-hand failure path, and then the result will then propagate through the pipeline, and it'll come out the other end. So the question is, how do we influence control flow in a pipeline? The answer is, it comes back to what I mentioned earlier. The monad pattern abstracts the data being passed through the pipeline. So if the get businesses method returns a result wrapped in we'll just call it an error monad, it'll tell the pipeline we need to detour to the left-hand failure path and propagate out. Okay, here's an inheritance diagram showing the control flow classes, maybe in either. So you have to think of this as there's two kinds of pipelines. There's a maybe pipeline and an either pipeline. A useful thing you can do to conceptualize a pipeline is to think of a pipeline the same way that you think of a function. A pipeline, or I should say a function, receives an input and then it returns some kind of an output. The way that a maybe pipeline works is that it will either return one data object or it'll return a special kind of monad called a nothing, which represents an undefined or null value. And either pipeline will always return one data object, but it will either return one data object or another data object. So coming back to our pipeline, let's look at the get businesses function in our pipeline. If we want a maybe pipeline, what we could do in the get businesses function is we could say check for an open connection. If there isn't one and we want it to propagate out of the pipeline, we would return a nothing monad. Conversely, if we are using an either pipeline, we're doing the same check, we would return a left monad, which is a failure monad, wrapping an error message that we want propagated out of the pipeline. So it's sort of like an implementation of exception handling. There are a couple possible applications of using a maybe pipeline. One would be something like if you're checking for a value in a collection. If the value exists, you would just return the value down the pipeline, or you would return a nothing. Another example would be polling. You may have a pipeline that's doing something like it's checking a port to see if it's open for a connection, and it's understood up front that most of the time the pipeline is going to fail. So you don't want it to keep spitting out error messages. You want it to just check for a null or an undefined, and if it's undefined, you just fall out. It's just a way of getting around that. So when I was doing research for this video, or sorry, not this video, this talk, I invariably asked the question, well, why are we implementing our own try-catch functionality here? Why not just use a try-catch? And I found a couple of answers. One is pure functions have no side effects. If a function throws an exception, that's a side effect. So the implication here is that any function that you are passing into your pipeline should probably be wrapped in a try-catch block. Also, utilizing these control flow classes kind of encourages you to decide up front how are we going to do our error handling within the pipeline. Using try-catch blocks, it isn't always clear where you put the try-catch. So the advantage is that everything is just contained right there in the pipeline, including the error handling. Okay, so before you attempt to understand, or I should say use the Pymonad library, it is critical that you understand how currying works and partial evaluation. Let's start with an example curry. So what curry does is, let's say that we have a function that receives 3 parameters, A, B, and C. And let's say we want a version of this function that only accepts an A. So we want to kind of preload it or preset it such that the B and C parameters are already configured. So we want something like this. The way that currying works is the first thing we'll do when we curry our function is we're going to configure the C parameter, then the B parameter, and then we'll be left with an A parameter. This is called right currying. It's called right currying because you're starting with the last parameter and then you're moving left. Conversely, there's something called a left curry. Let's use the same function that accepts A, B, and C. And we want a function pre-configured with values for A and B and a function that only receives C. So the way that currying would work with this, with the left curry, is we would first assign a value for A and then B, and then the result would be a function that receives C. So it's important to understand that curry, what curry does, it receives a function with multiple parameters and it returns a function that receives one parameter. So it's a way of pre-configuring or presetting a function with multiple parameters such that you have a function with one parameter. Here's an example of a right curry function. Let's look at an example of how to use this. So we define an add function, receives 2 parameters, x and y. And because we're right currying, we want to create a version of our add function that only receives x. So we need to configure the y parameter right away. So to do this, we would call our curry2 function and pass add in. So the result of this would be sort of like a version of the add function with the x and y parameters reversed. So if we then invoke the return function and pass in 5, it's sort of like an add function with the y parameter set to 5. And then if we invoke that function, passing 10 in, we actually call the function because now we have all the parameters. Again, it's important to understand when you're right currying, it's sort of like reversing the parameters. And here's how you would actually invoke it, just for clarification. You can see on line 12, we have a curry3 function. Note the names of the parameters being passed into the inner functions, starting with the third argument, second argument, and then the first. It kind of clarifies how you would use it. In the Pymonad library, there is an actual curry decorator function. You can see the usage of it over here. What you do is you pass in a number representing the number of parameters for the function you want to curry. The important thing to understand about this is that the curry decorator is a left curry. So it evaluates parameters from left to right. So why would we bother with a right curry function when there's already a built-in curry decorator? The reason why is if you use a right curry, you can create expressive APIs like this greater than function, which uses our curry2 right curry function. And here's how you would actually use the right curried function. It's very easy to understand. Greater than 10, and you're passing in 15. So yeah, 15 is greater than 10. It's a very useful little technique that I use a lot. Let's briefly cover partial. So there's a function in the Func Tools module called partial, and partial is not the same as curry. Again, a curry function returns a function that accepts one parameter. Partial returns a function with potentially more than one parameter. And it also evaluates from left to right, like the curry decorator. So an example of using curry would be, here's a function receiving 5 parameters. Let's say we want a version of this function pre-configured with values assigned A, B, and C. So we want a function that only accepts D and E. So this is how we would do it. We would use partial, pass in foo, provide values for A, B, and C, and then we have a function that accepts D and E. Okay, so let's move on to some of the Pymonad specific library functions. Here's an example of a pipeline. This would be a maybe pipeline. And as you can see on line 17 through 19 is where we're using the then method. And then is the method that accepts or a function that receives the data object flown through the pipeline, the function that does the operation on the data object and then returns it. So one way or one example of a maybe pipeline is here, and we're using an inline anonymous lambda function. Notice that the function is receiving one parameter, x. X would be the data object flowing through the pipeline. Alternatively, you can define functions outside of the pipeline. You can see in both functions here that we're actually passing in the value parameter. This is the data object. And then in the pipeline, we are passing the function in, but we're not invoking it. It's because there's an expectation that the function being passed in is receiving the data object as a parameter. What if we want to parameterize our pipeline? As you can see in this outline right here, we're actually passing values into increase value and decrease value. So in that case, we want to make sure that we pass in 2 parameters. Now let's look back at the pipeline and let's make an observation. So we're creating a maybe pipeline. We're passing in a data object of 70. It's an integer value of 70. And then on line 15, we are passing 30 into our function that processes the data object. So this is say we put a breakpoint on line 6. The question here is, what is the value of ink? And what is the value of the value parameter? This is why it's important to understand currying. It is critical to understand how this works. Okay, I'll give you a hint. notice that our increase value and decrease value functions are using the curry decorator, and the curry decorator is a left curry. That means the parameters are evaluated from left to right. So if you guess that the ink parameter is 30, pat yourself on the back. So the second parameter here, value, this is the data object flowing through the pipeline. So if you're using the curry decorator, which is left curried, then the carry forward parameter or the data object flowing through the pipeline is always going to be the last parameter. If you're using a right curry, it's always going to be the first parameter. Very important to understand. I believe that cost me about an hour or so when I was trying to learn this. Okay, let's move on to something I call a validate, transform, render pipeline. This is an example that should bring into, give us an example of everything we've covered thus far. So we're going to create a simple data validation API, starting with a function called validator. Validator encapsulates a predicate function and an error message to be displayed if the predicate function returns false. The predicate function is just it's a Boolean function, like isNumber would be a predicate. Here's how you would create a validator. You would initialize it with the error message in the predicate. So our predicate is making sure the value is greater than 0. And then if we test it with a negative value, you can see that it produces the corresponding error message. Value must be greater than 0. Otherwise, we pass in a valid value. 20 is greater than 0. It passes the validation. Checker is a function, is a very interesting function. You initialize it with a variable size collection of validators. So you initialize it with however many validators you want. And what it does is it returns a function that accepts a data object, and the checker runs all of its validators against the data object. And for every validator that fails, it accumulates a list of error messages. And then what it does is it returns either a list of all the validator error messages, or it returns an empty list. Here's how you use checker. So as you can see, we're giving it a understandable name, between 0 and 50. So it's clear what it's doing, and we're initializing it with 2 validators. The first validator is a predicate, making sure the value is greater than 0. And the second validator is a predicate, making sure the value is less than 50. And then when we run it, it's similar to checker. I'm sorry. When we run it, it's producing a list. If we pass, okay, let me backpedal. So if we use between 0 and 50 and we pass in 100, is 100 between 0 and 50? No. And the answer is the value must be less than 50. So we have that list that has the error message for that validator. Is 15 between 0 and 50? Yes. So there are no errors, so it returns an empty list. Now we're working with a Pymonad library. So what we want to do is we want to utilize those control flow classes we described earlier. So that's where the condition function comes into play. Condition is a light wrapper around the checker function that we just wrote. The difference being that the condition function runs a checker and all the checkers validators against a data object, and if it returns a list of error messages, then it'll wrap those error messages inside of a left monad. Remember, a left monad is the monad error object that you return, so that the pipeline will detour and propagate out as like an error. Otherwise, the condition just returns the object. So the net effect is you have a function that you pass an object into. It runs validators. If the validators pass, if it's a good data, it just returns the data object. Otherwise, it detours with left. The way that you use condition is identical to the way that you use checker. You basically just set up a condition, and then when you run it, notice that the result is showing left followed by the error message. In the case of an invalid argument passed in, so 100 is not between 0 and 50, so it's producing the error message. 15 is between 0 and 50, so it's just returning 15. That's very useful because in a pipeline, remember, the function you pass into a pipeline receives the data object, does something, and then returns some data object. So what we can do is we can actually use this condition inside of a pipeline. And that's what we're going to do in this validator example. What this pipeline does in a nutshell is it creates a person named tuple, which is immutable, passes it into the pipeline. It runs a precondition to make sure the person's valid. This is where you kind of like your validation is coming in. And then it's performing a transformation on the person by increasing the age. And it's doing it in a way that conforms to the rule of immutable data going in and out of the function. So it's cloning the person and making a new person that has an increased age. That's then passed into a post condition that makes sure that the age is within a range. And then it's passed to a function that renders the person as a string. And here is the code for that. Let's start at the top. First, we define a toString function for the person. It just renders the person name tuple as a string. And then we also define the person. You can see the fields being set. The interesting part is here where we're setting up the pre and post conditions. This is where we're using our condition function. As you can see in line 59, our precondition is basically setting up a couple of rules. It says the person has to be an adult, so the age has to be greater than 20, and the person must be a male. And then if we go down to line 63, we're setting up a post condition because we're increasing the age of the person. The post condition is just making sure the age is between 10 and 45. This is the code you see here. This is sort of like the transformation step of the pipeline. We're defining an increase age function that receives the person, the data object, as well as it's actually not a new age. It's supposed to be an increment, but and then we are using our left curry function to create another function called inc age, and inc age is curried, so we can use it in our pipeline. So the way that the person is initialized in this code right here is the person will pass both the pre and the post conditions. So this pipeline should produce the right result. And when we run it, as you can see, it's actually inserting the word right into the output. Remember that a right monad is the success monad. Let's say that we create an invalid person. Let's make a person that deliberately fails the precondition. So one of the preconditions said that the person has to be a male. So we're creating a female. And then we're giving the age of 0. So if we run this through the pipeline, we should have information about why it was invalid. And as you can see right here, it returned a left monad, and it has both validator error messages in it, telling us the person must be an adult and must be a male. So it's a kind of a nice, clean way of doing a very common operation of validation, validate, transform, and then render. Let's go over some caveats of using monads in the Pymonad library. One of the issues with using the monad pattern is the learning curve. There is a learning curve to it. In preparation for this talk, I discovered that firsthand. There is documentation online for monads, like monads in general, not necessarily Python monads. There's some, I don't even know if there's a video. I don't think I was able to find a video. A lot of the documentation that I found actually came out of books. And the worst problem you run into is trying to debug pipelines. The reason why is because it's hard for the compiler or interpreter to figure out what's going on with curried functions. So if you don't understand how to curry functions and correctly insert them into a pipeline, the compiler is not going to help you. It's going to be very difficult to figure out what's going on. Furthermore, if you go to the Pymonad library on GitHub, the README is out of date, or at least it was as of 2 days ago. The code examples in the README don't work. A lot of the documentation is using operators, and so it's very operator-heavy documentation. Fortunately, I went in and looked at the source, and the then method that we covered earlier does everything the operators does. It just does it better, and it results in more readable code. For anybody who's interested, if you're dead set on attempting to use the operators, there is an operators folder in the Pymonad library. I didn't really dive into it too much after I discovered that then does everything that the operators do. And that is pretty much it. I'm gonna go ahead and switch over. Oh my gosh. Okay, so we still have people in here. That's good. Okay, can anybody hear me? Oh man, I thought that I thought my mic was off or something. Okay, so I guess we're switching over to questions. It's supposed to be questions for the last 15 minutes.
Hey, are you able to hear me?
Yeah, I can hear you.
Hey, I'm curious about what you have found to be, if you found any particularly good or bad use cases for these versus other patterns that you could use in Python.
Well, I when I was initially learning about monads using Python, I was trying to apply. There was two projects that I used monads on. The first one was a script, a Python script that utilized a Yelp business web API, and I tried to design the entire script so that at a very high level, I'd have step 1, step 2, step 3, and step 4, and try to have those functions do everything else. And I kind of ran into some problems when I was doing it that way. What I learned about using monads is that you use them almost in the same way that you would use a function. So you may have experience when you have a class. Okay, say you write a class and you have a function that is using several other helper methods. So you have a helper method, and then you have another helper method inside of it. And so you're calling one helper method after the next, and you're passing parameters. I think in cases like that, especially if you're doing this from within a class, that you can actually eliminate, or you can group up all of the operations, all of the helper methods that you're using in your class. You can wrap them up inside of a pipeline. So you're replacing all of these cascading helper methods with a pipeline. So you want to use it. What I'm saying is you want to use it on a smaller scale. You don't want to try to design like an entire framework around it, if that makes any sense.
Awesome. Thanks.
Yep. Any other questions? Okay, I'll just take maybe another minute or two to just cover some other stuff that I didn't have time to squeeze in. This wasn't a completely comprehensive discussion about the Pymonad library. There's a couple of other classes I wanted to cover, but I didn't have time. There's one called the list monad. It's like a list alternative to using maybe and either. It allows you to handle pipelines that return more than one result. And then there's another class in there called state. which is another class that you can do to keep track of previous states as you go through a pipeline. But yeah, other than that, I would say that really the only thing you need to know is how to use the then method and then understand currying. Those are the two hurdles you really want to overcome. Okay. Yeah.
Thanks for this. This is super interesting.
Yeah, no problem. Do we, I guess we wrap up or? Okay, I take that as a yes. All right, well, thanks for coming.
Thanks. This is great.
Have a good one.
You too.
Bye, y'all.